Good morning, student. Let's start today's class. In today's class, we are going to discuss about going to discuss the naming of transistor terminals. That means our transistor, our PNP or NPN transistor have three terminals. That three terminals named how or that three terminals named. One is emitter, one is base, and one is cathode. Emitter and base are opposite side, and in middle there is a base. Okay, that is a base terminal. Okay, now see what is emitter terminal. Okay, emitter, this section is on one side that supplies charge carrier. The emitter, the name suggests, it emits the charge carrier. The charge carrier, it may be hole or it may be electron. Okay, and uh, and the emitter is always forward bias because due to it emits the charge, so that it should be in forward biased alwaysly. Okay, or every time it is should be forward biased, whether it is NPN or PNP transistor. Okay, in the figure you see the figure 1, the PNP transistor are there. So this emitter is P, so it forward bias according to the, or P side of the emitter is connected to the positive, and negative is connected to the N base, so that the PN junction, okay, the PN junction is a forward bias, is in forward bias, and the NP junction is reversed bias, which is collector side. Okay, collector is always reverse bias, and emitter is always forward bias. Similarly in NPN, N is connected to the negative, and P is connected to the base of P is connected to the positive. That is, it is forward bias, and this is reverse bias. Okay, this is collector side. And now let us see what is collector. Okay, the section on the other side that collect the charge is called the collector. That means in emitter emit the charge, and that emitted charge is collected by collector in other side. Okay, and this collector is always reverse bias. You see in the figure that this collector is always reverse bias. Okay, its function is to remove charge from its junction with the base. Okay, that means the collector function is to remove the charge from that this junction, NP junction. Okay, with with the base. Okay, or with respect to the, or with the help of base. Okay, and now see base, the middle section, which is very thin layer or lightly doped, is called base. Okay, and the base junction, the sorry and the base emitter junction. Okay, the BE means base emitter junction is forward biased, allow low resistance. That means if the junction is forward biased, there is no potential barrier, so a low resistance path is created for emitter circuit. Okay, and the base BC means base collector junction is reverse bias and provide high resistance in the collector circuit. That means the emitter circuit, a low resistance path created, and in the collector circuit there is a high resistance path created. Okay, now one thing remember, that it is very important note that the emitter is heavily doped. Okay, heavily doped mean there the emitter semiconductor is very that impure. That means impurity is very much or the high amount of impurity is added to the emitter semiconductor. Okay, that means emitter is highly doped, but the uh, base is base is lightly doped. Now that means the base is lightly doped, okay, and a collector is moderately doped. Okay, remember this point. Okay, emitter is highly doped, base is lightly doped, and collector is moderately doped. Okay, and now see what is the working of NPN transistor. Okay, the figure shown this NPN transistor with forward bias. Here you see in the figure the N side or the emitter side is forward biased. Okay, so the forward due to the forward bias, the electrons or the carriers, okay, in the majority carrier of the N side is all electrons, and so that the electron emitted or free electron emitted, and that free electron tend to combine with the that means the electron in N side, okay, the free electron which is emitted from N side is trying to flow, okay, trying to flow towards base. For that, for this flow or the for flowing the electron, we get our emitter current. This is our emitter current. Okay, and after flowing or after traveling electron from N to or emitter to base, in the base it tends to in the base the charge carrier or majority charge carrier is whole, so it tends to combine with the whole, or the free electron is try to combine with the free electron, but due to the base is lightly doped, okay, lightly doped, so that the amount of hole is very much less, that is about 95 or less than 5% of the produced electron. So very little amount of electron is combined here, and rest 95% of the electron is passed through the base to and reach in the collector side. Okay, and when the process of passing the process of passing of base is produced one base current, okay, IB, okay, produce one base current which is IB, and after that the electrons reached in collector side. Okay, in collector side what happened, in collector side what happened, that electron makes a or contribute a or produce a current which is called IC. Okay, these three current IE, IB and IC. IE is produced due to the free electron produced in N type. IB is produced due to the electron pass through the base. When the electron pass through the base, one IB current is produced, and after IB in N side there is one current is produced, what is IC. Okay, this is a collector side, and IB is IE is IB plus IC. Remember this formula. Okay, this means emitter current is equal to the base current plus the collector current. Okay, and now see what is the working of PNP transistor. Okay, similarly in PNP transistor the emitter side is forward biased. Okay, it should be, and the in P side or the P semiconductor, the majority carrier is whole. Okay, so here as like as the NPN transistor, the electron flows here, the hole flows towards the what towards the base, okay, of a N type semiconductor. Okay, and due to the flow of hole from P to N, or the emitter to base, okay, one IE current is produced, okay, and that hole combines with the electron or the majority charge of base, which is electron combined with holes, okay, but due to the base is lightly doped, the amount of electron is very less as compared to the amount of hole coming to them, okay. So less than 5% of the electron, or less than 5% of the hole is combined with electron in the base, and the rest 95% of the 95% of the hole is passed through the base. When it passes through the base, one current is produced in the base, which is called base current, okay, and after passing it reaches the collector side, okay, and the collector side one current is produced, which is IC, okay, and it is noticed that here in PNP, the current inside the transistor is due to the hole, okay. The current inside the transistor conduction, the current conduction inside the transistor is due to the hole, but the outside circuit or the outside circuit is, the current conduction is due to the electron. That means previously in the semiconductor, when we discussed about the semiconductor majority charge and minority charge carrier, I told you that the whole current is not considered in external circuit. In external circuit only the flow of electron considered, okay. So when the conduction is done due to the hole, there in that time or in that circuit, the current conduction due to the electron is in opposite direction. That means in the direction to the opposite of the direction of hole. The electrons flow direction is opposite to the direction of flow of hole, okay. Here you see the hole is traveling in this direction, but the electron is traveling in this direction, okay. That means opposite to the direction of hole, okay. Thank you.